How do you identify non-primitive Pythagorean triples? Imagine you have a set of 3 numbers that fit perfectly into the Pythagorean theorem. Now, how can you tell if these numbers are just a scaled-up version of a smaller, more basic set? That's what we're here to find out. When you see a Pythagorean triple, like 3 numbers that satisfy the equation where the sum of the squares of the 2 smaller numbers equals the square of the largest, you might wonder if it's a primitive triple or a multiple of 1. A primitive Pythagorean triple is one where the 3 numbers share no common factor except 1. But a non-primitive triple is just a bigger version of a smaller primitive triple. To identify these, start by confirming the numbers satisfy the Pythagorean theorem. For example, if you have 6, 8, and 10, check if 6 squared plus 8 squared equals 10 squared. That's 36 plus 64, which equals 100, and 10 squared is also 100. So they satisfy the condition. Next, find the greatest common factor of all 3 numbers. For 6, 8, and 10, the GCF is 2 because 2 divides all 3 evenly. If the GCF is greater than 1, then the triple is not in its simplest form. Since the GCF here is 2, this triple is non-primitive. It's just a multiple of the smaller primitive triple 3, 4, and 5, which also satisfy the Pythagorean theorem. Remember, all non-primitive triples can be broken down into a primitive triple multiplied by some whole number. For example, 9, 12, and 15 are multiples of 3, 4, and 5. Other common non-primitive triples include 16, 30, and 34, or 32, 60, and 68. Recognizing these patterns helps when solving problems involving right triangles, especially when you want to simplify or find the basic building blocks. So, to sum it up, check if the numbers satisfy the Pythagorean theorem, then find the GCF. If the GCF is more than 1, you're looking at a non-primitive Pythagorean triple. It's just a scaled-up version of a smaller, primitive set. This process makes it easier to understand the relationships between different right triangles and their side lengths.